So we need a chain rule. So let me give you take one on the chain rule. Okay? So this is going to be for the situation where I've got a function of x and y, right? And then x is a function of t and y is a function of t. Cool? Effectively, this means what?
Taking the derivative with respect to t.
Yeah, I want to take a derivative with respect to t, right?
Right.
Okay, so I'm thinking about something like this. Yeah. Yeah, so are these hard or partials?
Partials, because you have two variables, right? No.
It's just once you plug everything in, it's all one variable.
Yeah, so really I could think about this. Really, f depends on x and y, right? X and y might depend on t, but really this is f only has one variable that it depends on,
So
right?
it's really like
Right.
FLT.
Yeah, so this thing, I'm really looking at all three of these pieces of information, and I'm really just thinking, hey, SF is a function of t, right? But it has a weird kind of interpretation, right?
Yeah.
Really, this is some kind of a funky curve through 3 space, right, if I graph this thing? Okay, so let me say we've got df dt, right? Okay, so I'm going to start by thinking about, I'd like to know what this is, and I'm going to start by thinking about, could I approximate the change in f? You guys have a way to approximate change in f, right? If I didn't tell you that that x and y depend on t, what would you write here?
F minus F, or F naught?
Yeah, it'd be f, so we'd be looking for f minus initial, right? So the change should be what?
Oh yeah.
Okay, yeah, the slope.
So the slope in the x direction, right?
The slope in the y direction.
Times the distance you went in the x direction,
Okay, yeah. And then
plus
the slope in the y direction. And then delta y.
okay. But I wanted to talk about this in terms of t's, right?
Yeah, so then
So what's the change in x?
you change in t.
Yeah, that should be just, so this would be fx, and then change in x should be dx dt, right?
Okay.
Times what?
Delta the change in t.
Yeah, times the change in t. And then I should have fy, right?
And then dy dt.
dy dt,
And then change in t.
change in t. Cool. So your chain rule ultimately should say df dt is the partial of f with respect to
X,
x times,
the partial of f with respect to y.
Times the change in dx and t.
Okay.
times dx dt
Okay.
plus, now Jill,
Now, that thing I said, the partial of f with respect to y.
okay, partial of f with respect to y times
dy dt.
dy dt. Where'd the delta t's go?
You got divided by.
Yeah,
Delta
good.
f.
I wanted to get df dt, right? I'm looking for the change in f divided by the change in t. So here I wrote the change in f as some function of the change in t, and then I divided through by the change in t. You guys see that? So this step to there is divide by change in t. And take a limit, right?
Oh,
Oh
true.
yeah, the limit.
Okay.
Right? The limit gets rid of the soft equal, makes it hard equals, and replaces the change ins with d's, right? Cool? So here's one of your chain rules, right? And this is kind of in general the way I would approach, like, can I fiddle out a chain rule? Right? If you forget it, go to this kind of thing. There are going to be a couple of these, so it might be good to remember this fiddling process so you can get at them.